Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to Social Science online classes. The lesson for today's discussion is complex numbers. We will continue from where we left last time. Alright, so we had stopped at question number 6 of the exercise 5.1. I hope you remember, right? So we had stopped at question number 6, and the sixth question was an assignment for you. Okay. Now we'll continue from the question number 7. What you have to do here is you have to express the complex number in the form of a plus ib. The question goes like this: you have 1 by 3 plus I into 7 by 3 plus you have 4 plus I into 1 by 3, right? Then minus 4 by 3 plus I. Alright, so this is the question that we have. See, this question is not very difficult. Just because you see fractions, don't think this is a complicated one. Very simple question. Okay, so what you need to do is just get rid of these brackets. Alright, so what we can do here is first 1 by 3 and look at this is addition, so you don't need these brackets anymore. So I am eliminating these brackets first, and I will write real numbers together. Okay, so real parts together. Then I will take I common out of these two things. So 7 by 3 plus 1 by 3 here minus, let's multiply, so that will be plus, and 4 by 3, so minus, this will be I. Well, now the job is very simple, so you got to write the real parts. You can write these things together. You see, this is 4, but before that I will write 4 by 3, right? So I will write 4 by 3 here, and this is plus 4. Then once again I am taking I common. Okay, then this will be 7 by 3 plus 1 by 3, and here I am taking I common, so this will be minus 1. Well, now you got to simplify these two things. That's the end. So this is 3. So take 3 as the LCM. So this is 1 and 4, and how much you got to multiply here? 3. So that will be 12 plus I common. Now 3 LCM again. So this is 7 plus 1, and how much you got to multiply here? 3. Therefore, you have arrived at this step. Now what is left is just add the numerators. That's it. Okay. So how much do you get here? How much do you get? Okay. So 1 plus 4, 5. 5 plus 12, 17. So this is 17 by 3. And then you have I. And 7 plus 1, 8. 8 minus 3 is 5. 5. So this is 5 by 3 and that's it. Okay, so you have got a complex number in the form of a plus ib. Okay, so that was the question for you and here is the answer. Well, so that is question number 7. Now the next one, question number 8. Okay, these are all silly questions, you can solve them very quickly. Okay, so question number 8. You have to express the next question, given thing in the form of a plus ib. So 1 minus I to the power 4 is the question. 1 minus I raised to 4 is the question. Okay. Now what you will do? You have to the power 4. If you know the formula, use it. If you do not know the formula, then use whatever the formula that you know. Okay. So which formula do you know? You know whole square. So you can write whole square. Okay. Or you can write this way. You can just split that 4 and write square and square. When you multiply, powers will be added and hence you get 4. So what I have done is I have split the powers. Okay, bases are same. Next, you have to use a minus b whole square twice. So use it. So what is it? 1 square, 1 itself, plus I square. I hope you understood. A square plus b square minus 2ab. So minus 2 into 1 into I. Right? Now next this is also a minus b whole square. So the same thing is repeated. Okay. So this is 1 and I square and minus 2I. So you could write whole square here. Okay. You could write square and whole square. That is also fine. So just to make things clearer, I have written this way. Okay. Now, what is I square? Just replace it. So that is minus 1 minus 2I. And this is once again same thing. I square is minus 1 and this is minus 2I. Okay. Now, 1 and minus 1 cancels. So you are left with minus 2I into minus 2I. So which is equal to minus with minus plus 2 into 4I square. Now I square is minus 1, therefore the final answer is minus 4 plus I 0. That's your answer. Okay, so say you could do this in an easier way. You could write whole square here, it would get easily. But if you are getting confused with that method, this method looks simple. Okay, so only thing you have to do is multiply here, and after that replace I square. So all these problems are based on only one rule, and that rule is okay. So if you remember this much, you can solve any problems of this type. Okay. So let's continue and solve question number 9. Okay, so question number 9 is 1 by 3 plus 3I whole cube. Now you can use a plus b whole cube formula. If you need, I write the formula. So a plus b whole cube formula. A cube plus 3a square b plus 3ab square plus b cube. So what you can do is you can write a cube plus b cube plus 3ab into a plus b. That formula is also fine. Doesn't matter. Okay? So there are two variations of the same formula. So what I am using is this particular formula. Now a is 1 by 3. So 1 by 3 whole cube plus 3 into a square. A square is 1 by 3 square here. And then b. So b place it in there. 3i. So 3i. Next 3. A plus 3 1 by 3. 1 by 3 here. And then b square. So b is 3i. So 3i square. Then well, so what is the next step? Next step is b cube. So b placed in the way, b placed the 3i raised to 3i whole cube. Alright, so that completes the substitution. Now simplify it. So 1 cube is 1. 3 cube is 27. 3 cube and then 3 into 3 into 3. Okay. Now this is 3 here. 1 by 3 whole square. So 1 square, 3 square is 9, and then the I. Here, straight away you can cancel 3, and this is 3 square 9 and I square plus, see 3 cube here, so 3 cube is 27 and I cube. Well, now what are the things you can replace? I square and I cube. So these are the two things you got to replace. So what is I square? I square is nothing but minus 1. I cube you can write it as I square into I. So minus 1 into I, and that is minus I. Right? So those are the two things you have to replace here. So this is 1 by 27 plus 3 into 3, 9. 9 and 9 cancel. Okay, so that is only I. Right, so 3 1s are 3 3s are. Again 3 cancels. Right, so therefore it is only I. And this is like 9 into minus 1. And this is 27 into minus I. So minus I. Well, now write the real parts together. That means you write 1 by 27 minus 9. Okay, plus you take I common. So this is 1, and here minus 27. Okay, so now what is left is simplification of this fraction, and this is very simple thing. Okay, so take LCM 27, and this is 1 minus 9 into 27, correct? So that is 270, 243. So this is 243. Right. Okay. Then this is I into minus 26. Okay. Finally, 1 minus 243. That is minus 242. So this is minus 242 divided by 27 plus I into minus 26. So this is of the form A plus IB, and that's your answer. Alright, so what you are asked to do here, convert this non-standard form into the standard form. A plus IB form alli baribeku ನೀವು. ಇದು A plus IB form alli ಇಲ್ಲ. Okay, whole cube ಇದೆ. A plus IB ಅಲ್ಲಿ square cube ಎಲ್ಲ ಯಾವುದು ಇರಬಾರದು. A plus IB ಇರಬೇಕು. Real part plus I into imaginary part ಅಷ್ಟೇ ಇರಬೇಕು. Okay, so that was your job here. Okay, so similarly you have question number 10, and that is okay, so you have minus 2i minus 1 by 3, you have minus 2 minus 1 by 3i whole cube. So once again you can use the A plus IB form. I will tell you how. You can take this minus common. Okay, so how we can do this? So this is minus 1 into 2 plus 1 by 3i and whole cube. Right? Okay. Then you can do this like -1 whole cube and 2 plus 1 by 3i whole cube. I hope you understood this. Okay. Now what you can do is -1 whole cube, -1 into -1 into -1, which is -1. And here a plus b whole cube formula you can use. So just refer the previous answer. There we have written the formula. So if you need, I'll write the formula again. So a plus b whole cube, a cube plus 3a square b. Then 3 ab square plus b cube. So you have a cube plus 3a square b plus 3ab square plus b cube. Use that formula here. First is a cube. So a cube plus a link, 2 cube on the way. Next 3a square into b plus 3a into b square. So that is 1 by 3i square. Next b cube. B cube means 1 by 3i whole cube. Well, use the brackets properly. So this is minus. Okay, if a minus 1 then write -1 itself, or just minus is enough. Now 2 cube is 8 plus 3 and 3 gets cancelled. You have 2 square 4 and you have I. So that is a simple thing. Now again you have 3 into 2, 6, 1 square is 1, I square divided by 3 square 9 plus you have I cube divided by 3 cube, which is 27. Okay, so let me continue here. Next, what you can do is you can write, you can replace I square and I cube. So that's what we will do in this step. So you got a there, and then you got 4i, and I square is -1, and this is 3 2s and 3 3s. Sarina alva. So ಇಲ್ಲಿ 2 by 3 ಬರುತ್ತೆ. So 2 by 3 into I square is -1. Remember, I square is -1. What is I cube? -I. So just like in the previous problem. Okay, so I square is -1. I cube is getting -I. Correct. Well, next what do you have? What you have is -2 by 3 and 8 must be written together. So you know the real part of the complex number 8 and -2 by 3. Now you have got I here and I here also. So this is 4i minus I by 27. So if you take I common, you get 4 here, and this will be 1. Well, so you got to simplify these two fractions. That's the end. And of course, there is minus sign inside. You can multiply that later. Okay. So now take LCM 3. So if you have taken LCM 3, you got to multiply 3 here. So 8 is 24 minus 2 here plus I, and multiply 27 into So how much do you get? 108, correct? So that is 108. Wait, I'm sorry. 108, correct. Then minus 1. Well, so this is like 24 minus 2, 22 divided by 3 plus I into 107 divided by 27. Now the final step, multiply minus inside. So what I get in here, minus 22 by 3 plus I into that minus, you can either multiply here or you can put that minus inside the bracket as well. So this is minus 107 divided by 27, and that is like A plus IB, where A is minus 2 by 3, 22 by 3, and B is minus 107 by 27. So finally ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ A plus IB ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆಯಬೇಕು. So ಅದು A ಮತ್ತು B negatives, positives, they can be negative real number or positive real number. So ಇದು fraction ಇರಬಹುದು. Okay, so it can be irrational also, it can be rational, it can be even irrational, doesn't matter. Okay, so that completes the problems where you have to express the given complex number in the form of A plus IB. Alright, so well, I hope you have understood whatever is explained so far. Now we'll move on to a new concept, that is modulus and conjugate. Right. So for next 5 or 10 minutes, we'll just understand what do you mean by modulus and conjugate. Okay. The first one, modulus, and next is conjugate. Of a complex number. Well, first let z is equal to A plus IB be a complex number. So what are we doing? We are considering one complex number consider ಮಾಡೋಣ ಸರಿನಾ ಇವಾಗ what do you mean by modulus? Let us understand that. So then modulus of z, modulus of z is defined as square root of a square plus b square, and it is denoted by so how it is denoted? It is denoted by this symbol. So this is modulus of z, mod z you can call it. Okay, so that is the symbol and this is the formula. So I am combining them, I am writing them together. That is mod z is equal to square root of a square plus b square. So this is it. That's how it is defined. Okay. Now let us understand the example. So for example, if z is equal to 2 plus let us say 3i, then what is mod z? Square root of is 3b. Therefore, this is 3 square. Remember, there is no I here, so don't write I square here. It is only the real part and the imaginary parts squared and added under the root. Okay, so first you have 2 square, which is 4, and plus 3 square, that is 9. So that is under root 13. So square root of 13 is your answer for this modulus of z. So that is a very simple concept. The question is straightforward. Find the modulus of the complex number. This is what you got to write. Alright. So it is a straightforward question and a simple answer. Well, now what about the conjugate of a complex number? Let me take the same example. Right. So let me take the same example. So what is the meaning of conjugate? See, conjugate is written this way: z bar. Okay. And this is like 2 minus 3i. So what is happening here is the real part remains the same, but the imaginary part changes the sign. Okay. So this does not become minus. So that remains the same. But if this is positive, you should write negative. But if it is already negative, you should change the sign and make it positive. So how do we define? So let z is equal to a plus I be a complex number. Then the conjugate of z is defined by b minus ib and denoted by z bar. So therefore, z bar is equal to a minus ib. Well, so this is example. So if z is equal to 2 plus 3i, z bar is 2 minus 3i. So if we take one more example, if z is equal to minus 1 plus 2i, then what is the conjugate? The conjugate is minus 1. Okay, so real part remains the same, does not change, real part change. Imaginary part sign change. So plus becomes minus here, and that's how we can write the conjugate of the complex number. Okay. So why do we need them? So we need this modulus and conjugate for the next concept. Okay. So that I will explain in the next class. So that's all for today's class. Thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.